Alrighty, so thank you for coming to my talk today. My name is Spencer Heywood, and today I'll be sharing some ways I've been using Docker to augment my security role. For those of you who don't know, I work at the Utah Education and Telehealth Network as a security analyst. I hope to share some ideas on how Docker can be a great tool in your tool set, especially for security workflows. Today I'll be sharing some ways that you can integrate Docker in with your shell specifically. So on Unix specifically, I'll be going over the bash shell and the fish shell, because fish is what I use as my daily driver for my shell. As noted on the first slide, please check out the slideshow and the links for your own reference at https://saintcon2019.netlify.com. Another objective that I hope to accomplish during this presentation is I hope to also shed some light on the potential risks with using Docker as well. We're going to be going over a lot about how to weaponize Docker quickly and efficiently. For me as a security analyst, that's a great tool, but in the hands of a malicious user, Docker can be weaponized super quickly. So hopefully by the end of this talk, you have some ideas on how you could use Docker to augment your own security workflows, but also some things to look out for while using Docker. To give a little bit more of a background of myself, again, I'm a security analyst, a senior security analyst at the Utah Education and Telehealth Network. Been there for about 2 years. My background is in Linux systems administration, and I really enjoy learning how to use open source tools to greatly improve my own life and also my career professionally. I've been using Docker for about 4 years now. But throughout that time, I would say I've only maybe spent about 2 years actually learning how it works and getting used to all of the jargon and things that come along with it. So one of my objectives today is for those who aren't super familiar with Docker to distill some of the basic concepts behind what Docker is, what a container is, and then move eventually over into how you can use it to augment your red team security workflows. As the title of my presentation suggests, I'll be talking about using your shell in conjunction with this. So again, relevant disclaimer, I use fish as my shell, but since bash is most common on most Unix systems, I'm going to be covering bash as my main focus. And unfortunately for Windows users, you could do a lot of the same stuff in Powershell. I don't use Windows, so I haven't taken the time to do the work to make this work on Windows, but I know you can do the same thing. So first we'll get into what Docker is. Docker is a cross-platform container service that can run Linux and Windows applications. Docker uses OS-level virtualization, and Docker containers utilize a single operating system kernel. This means that a Docker container is typically more resource efficient than using a virtual machine. Another thing to note is that if you're going to use Windows Docker containers, those only run on Windows. From what I understand, Docker leverages some Hyper-V magic, so if you want to run Windows containers on Linux or Mac OS, it's not going to be possible. Now, what exactly is a container? So I've said the word container a few times, so I think it's good to define it, so that way we're all on the same common ground. So a container is a very tiny machine with a prepackaged piece of software. So I often compare them to very, very small virtual machines. On Linux, containers are possible due to a functionality of the Linux kernel called C groups, which was mainlined into the Linux kernel in 2007. C groups allow multiple isolated Linux systems to exist on a single control host. And C groups are also in charge of negotiating resource usage and assignments between those containers. A comparable function exists on Windows called job objects, which I believe, if I was doing my research right, I believe job objects were introduced in 2014, and I believe it was for containers and that kind of workflow to exist on Windows. Unfortunately, Mac OS does not have any sort of C group-like functionality. So if you want to run Docker on Mac OS, you can, but it installs a Linux virtual machine that allows you to have that C group functionality in the background. That being said, though, I use Mac OS for my position every day, and I have not seen any significant performance issues or latency caused by that virtual machine. So Docker isn't the only container technology that's available. I think that's good to go over as well. Docker actually leverages a container runtime called containerd on Linux, which was actually developed with Docker containers and Kubernetes in mind. Nowadays, you can actually use containerd without needing to use Docker. But there are also some others. There's LXC, which stands for Linux containers. That is actually present on Chromebooks. So if you have a new-ish Chromebook and you run the Linux apps functionality, that's made possible through LXC and Linux containers. BSD has also had containers for a very long time. Since the year 2000, they introduced jails. So from what I understand, I think BSD was the first one to ever start using containers and that type of functionality. So the primary reason that I use Docker is because it's cross-platform. You can have these workflows exist between Windows, Mac OS, or Linux. Although the Docker daemon on Windows is a little bit different than on Linux or Mac. Again, all of the same workflows that I'm about to share today can exist on Windows. I just haven't tested it myself. So the reason I prefer it to be cross-platform is because I use Linux and Mac OS. It's nice to be able to just move between platforms and have the same types of applications available and workflows available. Docker is also really popular, so it makes it really easy to find support and also applications available on Docker Hub. The Docker documentation is also very well developed and readable. However, I do have to admit that in order for the Docker documentation to actually be useful, you kind of have to understand the jargon and a lot of the ecosystem before you get into the documentation itself. So hopefully, by the end of this presentation, you'll have a lot of that jargon understood if you didn't already. Finally, another big win for me is that you can use Docker for free and it's open source. To clarify, Docker Enterprise is not free and open source. That's a paid service that's offered by Docker itself. But the core engine powering the Docker Community Edition and the Enterprise Edition are the same. Some of the features that come with the Enterprise Edition are things like vulnerability scanning, same-day Docker support, but overall, the same core functionality is present in the Community Edition versus the Enterprise Edition. So don't shy away from using the Docker Community Edition because it's labeled Community. It's definitely enterprise ready and in production by lots of different companies that are out there. So now let's take a look at a Docker file. So a Docker file is the file that contains the build instructions for a Docker image. So these are all of the commands that will be run when you build a Docker image. So as a result, looking at the Docker file of a container tells you a lot about what that container is for, how it's provisioned, and so on. So some of the base, if we look at the front, or at the beginning of this Docker file, we can see this from Ubuntu statement, and that states that we will be using the official Docker image, Ubuntu Docker image, as the base image for this newly created image that we'll be running. And then you see the next command, the run apt update and apt install telnet or netcat. We're just telling the container to install telnet or netcat. And then finally, the cmd bin bash, that tells us what the default command will be within the Docker container itself. So this kind of workflow would be really useful if you wanted to run telnet or netcat at a time. So like kind of an ad hoc container creation, run telnet, and then the container could destroy itself and not exist anymore until you need it to run again, to run those single commands. That would be kind of the workflow behind this type of Docker file. So before getting into Docker for security, I think it's a good idea to understand a little bit of the commands behind it. So if you look here, we have the Docker pull command. This will pull down a Docker image for you. And then the Docker run command will, if you don't have that image pulled down already, it will pull it down for you, and then it will run whatever command you tell it to next. So in this example, we're running Docker run, and it will echo hello world. That will be the command it runs once the container is provisioned. In the next command, we see that we're running an Ubuntu container again, but this time we're going to try to get an interactive shell using bash on the container itself. And once you exit out of that shell, the container will destroy itself with the --rm flag. Then here are some other basic commands as well, such as Docker ps to list your running containers, Docker stop to stop your container, and Docker rm to remove the container that you have stopped. And then finally, if a container is stopped and you want to start it, you can just do Docker start container ID. So again, before getting into the security portion, I think it's good to understand the design principles behind Docker. So that way you can know what Docker is good for and what it's not good for. Because I know for me, especially when I started first getting into this technology, I just wanted to use Docker for everything. And while I think it can be used for a lot, there are times where something else should be used, such as a virtual machine or maybe not any virtualization at all. So first, Docker containers are meant to be super minimal. Typically, the underlying operating system within the container is very small in relation to the actual storage space it consumes on the host. For example, a common Linux operating system used in containers is called Alpine Linux. And the 64-bit version of Alpine Linux meant for use in containers is a 2.6 megabyte download. I checked that yesterday, and if you go to download Alpine Linux, the container runtime, again, 2.6 megabyte tar.gz file. It's a really small operating system. As a result, you have a really small footprint and lots of resource that's not dedicated to the operating system on the container, but actually whatever application you need. Being so small, containers often lack applications and system tools that are most often present in a typical Linux environment. Containers often only provide the most basic tools specific to their function, such as network functionality, a package manager, and other very basic network tools. So if you're tempted to bootstrap a tool on top of a container, you probably shouldn't, or you should make your own container image yourself. I found that when I find that a Docker container application that I want to use doesn't have an application, sometimes I've been tempted to do this as well. So I'm talking from experience. If you want to throw something on top of a Docker container, you probably shouldn't. Make your own image. It kind of defeats the purpose of the design principles behind this. With the minimal nature of containers in mind, they are typically built for a single purpose. So typically they have a single piece of software that accomplishes a single task. If you have an application that requires a stack of software to run, such as a web application, it is often most common for each piece of software to be running in separate containers that get linked together. So as an example, we could look at a web application. A web application typically requires database functionality, which isn't necessarily exclusive to the web application. So as a result, for a web application, let's say WordPress or Joomla, often you will have a separate container created for the database, and then another separate container that links to that database that actually runs your web application. Hopefully that makes sense, but I think that illustrates the point of why it's important to keep things modular in Docker, because you can reuse database containers wherever you need to based on your application. While that may not be a specific feature we care as much about in security, I think it's still good to go over. So next, running applications in containers provides a layer of security. As the containers have their own kernel, processes, and isolated environment, they can protect the host running Docker and other containers from getting exploited should a container get compromised. And by default, containers are completely isolated and cannot be communicated with unless you explicitly specify them to be accessible from other machines. So again, if you spin up a Docker container and you don't expose any ports, any networking within that container, you won't be able to communicate with that container except through the Docker daemon. So again, once you create a container, it's totally isolated from whatever resources, or it's totally isolated unless you specify what resources it should be able to access. So with some understanding of Docker principles, I think it's time to start going into Docker for security, since that's what this talk is about. One of the ways that I've been using Docker for my security workflows is by running my security tools in Docker containers rather than installing them on my machines. Some of the tools that I have started running in Docker are Nmap, Metasploit, Derb, which is short for Derbbuster, Hydra, and Gscript. My primary reason for doing this is because it allows my security workflows to be totally portable between machines. All I have to do is install Docker on my new machine and then configure my shell to begin using those tools. This allows for Docker to almost behave like my package manager. Traditionally, before I started doing this, I would use a Kali VM, which I think most people do. There's nothing wrong with a VM, but what I found is that it's kind of a cumbersome task to, especially if you just want to run a simple tool very quickly within Kali, it's kind of cumbersome to have to power on the VM, wait for it to boot up, log in, and then run whatever you need only to power it off again, unless you leave your VM in a permanently suspended state. So Docker kind of supplements that for me. It gives me my ability to just run commands super quick in another environment and then have that environment destroy itself. So running your security tools in Docker also keeps your tools isolated from your machine. Many security tools aren't necessarily built using the best development practices, and they're often just meant to get the job done. I know that I've written my own security tools that they get the job done, and then I don't take too much time worrying about development best practices. So likewise, there are lots of other security tools that aren't necessarily following best practices. So it's probably not best for you to install them on your daily driver if you don't have to. So finally, Docker containers typically use less resources than a virtual machine, and that's due to the single kernel operating. I think that's what the term that they phrased. But anyway, because it's so minimal, Docker containers will consume a lot less disk space, RAM consumption, CPU, typically in comparison to a virtual machine, especially Kali. Kali isn't necessarily the most lightweight machine to have around. So one significant downside to running all your security tools in Docker is that Docker commands can get pretty long. So in order for me to fix that, I started writing these aliases. So in Bash, you can have aliases, which essentially serve as shortcuts to longer commands or commands you just don't want to memorize. So if you use a Bash alias, you can have a super complex long Docker command distilled into a single command. So for example, the following nmap command in Docker, which looks like that huge command, could be made into a Bash alias, which you would only have to create once. And then, as you can see in the bottom portion, you could run the nmap Docker command or alias just using nmap and then whatever arguments you need after that. So initially, this sounds like a lot of work, and believe me, it is. I've done a lot of this for my own personal use, and it is a lot of work to get this type of workflow in place. But you only have to do it once. And on top of that, I compiled a huge list of Bash aliases as well as fish functions in order for you to start using them today. So all you would have to do is copy the aliases that are linked in that GitHub repository that's on this slide, copy those shell functions, configure them in your shell to be loaded on every time you get into the shell, and then once that's done, you basically have an entire pen testing kit on your machine, which is really nice because, again, you don't have to worry about moving virtual machines. You don't have to worry about creating virtual machines. It's super portable. So here are some examples, and I'm actually going to go over these. I'll demo these for you. It's not anything super fancy, but here are some of the commands that I've been able to throw in those fish functions and Bash aliases. So, for example, we have nmap, metasploit, and openvos. So that way you could use these tools on the fly on a new machine, assuming your shell is configured and Docker is installed. So I'll give you a little bit of a demo so you can see it in action. So just one sec. So yes, okay, you can see my shell. So let me see if I can, just one sec. Can you guys see that okay, or is that too small? Too small? Okay, I'll see if I can increase the size real quick. Okay, looks like that won't work. Okay, well, anyway, I don't have this. Yeah, that's even smaller. Okay. Well, anyway. Yeah, I'm trying that. It's not working. So let's see. Yeah, it looks like this demo is going to fail. Well, anyway, I'll just read out for you what I'm doing so that way you can understand. So again, I have these bash aliases and fish, so I'm using fish as my shell. So again, get this same workflow running in bash. But anyway, so in order for this to work, you have to have those pre-configured, which I've already done. And then let's say I wanted to run nmap, and let's say I wanted to do a privilege scan. So right now I'm VPN'd into my home network. Yeah, with how small it is, you guys probably can't see this at all, so sorry about that. Well, anyway, so I'm typing in nmap-ss, and then I'm just going to do the port scan that I want to do. So normally this is a privileged scan, but in Docker, since Docker is a privileged service, I can run it without needing to provide sudo of any sort. Anyway, so that runs, and I'm just going to quit that because I don't really care about scanning my home network. But anyway, so that will run, and that works. Another example is Metasploit. Rather than spinning up a Kali VM, I can just type in MSF console and hit enter. And again, I'm aware that you guys can't see any of this, so you'll just have to take my word. Hey, nice graphics. So yeah, there's Metasploit. I don't need to install Kali. I just install Docker in my shell. I have Metasploit available for me for quick use. And then finally, if I wanted a quick, I wouldn't say OpenVAS is necessarily the greatest vulnerability scanning tool out there, but if I wanted to do some quick vulnerability scanning, I hit OpenVAS, that runs up, and there's OpenVAS. So I can start doing some vulnerability scanning on the fly without needing to take the time to learn how to install it, or, I mean, I already know how to install it, but without taking the time to set it up. I know that can be quite a cantankerous process, so. Again, it's just a shortcut for you to start using these tools very quickly on the fly. So just one sec. Just going to stop that Docker container so my CPU stops flying. Actually. All right. So anyway, as I've shared, this is a really awesome tool for you to start doing stuff, start doing your security stuff on the fly, but as I said earlier, this is also in the hands of the wrong person. Access to the Docker daemon can do quite a bit of damage. As you saw, I can spin up Metasploit, I can have a Metasploit shell in an instant, I can start using that, I can start vulnerability scanning on the fly. So again, Docker is kind of a dangerous tool in the hands of the wrong user. So the potential risks from Docker come from the fact that it's a privileged service. So I'm not going to be focusing mainly on the potential software that's available at Docker Hub, because that can be questionable as well. But the potential abuse that can happen while having access to the Docker daemon is tremendous. So again, please keep that in mind as you start using this for your security workflows. Some simple security tips to secure your Docker instance would go a long way to make it a lot less risky. So, for example, if Docker won't be used regularly, don't install it. And especially in shared environments, this is where it's most risky. If a user in a shared environment doesn't need access to the Docker daemon, for example, by adding them to the Docker group on a Linux system, don't give them that access. Another thing is that you can always use, or you should always use official and verified images from Docker Hub. If for a specific reason an official image won't do, I would first recommend writing your own image. As we saw earlier, Docker files are not very complicated. But if you're going to resort to a third-party image, always look at the Docker file associated with that image, if it is available. Sometimes it's not available, but if you do some digging, typically you can find the Docker file on GitHub, on Docker Hub itself, if you just look around hard enough. And then if Docker's being used in a corporate environment, I would also recommend that you look into self-hosting your own Docker registry instead of allowing access to Docker Hub, because malware being embedded within Docker containers has been found before. So if you want to just maintain your own safe set of Docker images, tools like Portis and the GitLab Docker registry, as well as Docker themselves, allow you to use the Docker command to host your own registry. I would highly recommend that you host your own registry in an enterprise environment if you're unsure about trusting Docker Hub. And again, all of these risks, they don't mean that you shouldn't use Docker, but I think they definitely are, they should be kept in mind as you start using Docker and as you rely on it heavily. And I think it's really important that you understand this for your end users, especially if you're giving them access to Docker. Because again, like has been shown, it's so easy for Docker to be used maliciously, as there's so much security software that's available on Docker Hub. So I would highly recommend that everyone start using Docker if you haven't yet. It's really maximized a lot of convenience and a lot of my security functions. It's really helped me out a lot, and I definitely suggest you check it out. So if you want to get started, I would first recommend installing Docker Desktop on your machine, and then I would just start messing around with it. Next, I would look at the shell config files that I've shared in this presentation if you want to start using it for security specifically, especially if you want to have highly accessible, highly available security tools in your shell. And then the Docker command itself has lots of arguments and features, and you could probably spend tons of time just digging into that as well. And then finally, once you rely heavily on Docker, I would recommend looking into best practices with Docker, as there's just so much that you can improve. So that's all I have for today. Before we conclude, are there any questions? Any questions about Docker or these security boards? Yes? Yeah, that's a good question. So the question was, do I use a program to manage my dot file? So yeah, so for those who don't know what dot files are, they're a set of config files that you store somewhere. And so I have my dot files on GitHub, so I can sync all my bash and fish stuff immediately between machines. I use Git, obviously, to clone my dot files, and then I use Peru to download third-party stuff that's not in there. And then I just use symlinks to link all of the config files where they need to be linked to. Yeah, any other questions? All right, it looks like that's it. Thank you very much.